All right, welcome to Chapter 2. Chapter 2 is about motion in one dimension. This is a challenging chapter. You need to understand it because in future chapters we'll be doing motion in 2 and 3 dimensions. So if you don't understand this chapter, the next few chapters will be impossible. So make sure you spend enough time to understand this chapter. So here are the objectives. Describe problems in different representations, graphical, pictorial, mathematical. We're going to keep talking about kinematic variables like position, velocity, and acceleration. We'll use kinematic variables to describe horizontal, vertical motion. We'll learn basic problem-solving skills, including a basic problem-solving strategy that, yes, we'll use throughout the entire semester. And you might think this is cumbersome at first, but I promise you, if you just follow it, you're very, very likely to solve the problems correctly. Yeah, and then we're going to solve problems. One dimension, uniform motion, motion with constant acceleration, including free fall. All right, let's talk about graphs. Now this is x in meters, so it's a distance or position, time, minutes, whatever. All right, so this is called a position versus time graph. And we're going to use these a lot in class, and you'll use them a lot in lab as well. So what I'd like you to do is, as soon as I'm stop talking, pause the video and ask yourself what kind of motion is going on here, here, and here. So you should be able to figure that out from what you learned in Chapter 1. So pause your video and figure that out. All right, we're back. Now, position versus time, and we have straight lines. So we have different slopes. So as you learned, hopefully a long time ago, the slope is the rise over the run. Here, it's delta x over delta t, and that's velocity. So here, the slope is constant. So that means that the velocity is constant. It's called uniform motion. The direction is the same, the speed is the same. Now here, this is another straight line. So it's constant motion, and this is constant motion. But obviously, okay, this slope is larger than this slope. So this velocity, or speed, the speed here is faster than this speed. And this speed is the fastest of them all. All right, next one. Okay, do the same thing. Pause your video and ask yourself what's going on here. And refer to this. All right, so here it's a horizontal line. So delta x is 0. So the velocity is what? 0, because the slope is 0. Okay? Here, this is a negative slope, so that means the velocity is negative. Remember, we indicated in Chapter 1, if we're going to call this direction positive, this direction is negative. And then here, again, the velocity is 0, and then here the velocity is positive. So basically, for the first hour, let's say it's a person. For the first hour, the person is at 40 miles away from the origin and just sitting there wasting time. And then for the next hour, the person goes in the negative direction really, really quickly. Then for the next hour, sits down, wastes time. Then for the next hour, kind of slowly goes back to the right direction. So again, you need to understand these graphs. You'll be using them a lot. All right, so we're going to have some practice. So what we're going to do is we're going to pretend that, so we're going to make a coordinate system, one-dimensional coordinate system. So somewhere around here we're going to call 0. Maybe put a chair. So this is going to be 0. and this is going to be plus, and this is going to be minus. So it's just like we always talk about. That's plus direction, that's minus direction, and that's 0. All right? So again, this is 0. Okay? Now, so I'm going to walk across the room and in a certain way. And what I want you to do is after I walk across the room, pause the video, and I want you to draw a motion diagram, a position versus time graph, which is just what we talked about, and then you should be able to figure out a velocity versus time graph. And I want you to include proper units and labels. So do a good job. All right? Okay, let's see. And yeah, one more thing. So you can't see over here, all right? You can only see when I cross this line. And then you can't see over here. You can only see up to this line. So basically all you can see is from here to here. Okay? All right. Here we go. Okay, so pause your video and do all that. All right, so I'm back. Okay, so what kind of motion was that? I was walking at constant speed, so that's uniform motion. So there's the motion diagram. You can see that now we're labeling the velocities. So this is the same distance as that, same as that, same as that. All right, so the velocity is constant, but also I was walking in that direction. So that means it's positive velocity. Okay, so again, this is just a tool to help us figure out what we're talking about, what kind of motion we're dealing with. Okay, now, this is 0, that's plus, here's minus. So I started over here at some negative position. And that's why, you see, I started at a negative position. I was walking to the right, so remember, this is position versus time. The slope is velocity. My velocity is constant, so I have a constant slope. So I started over in some negative place. I crossed the 0 point, and then I continued with constant speed. So that's the correct position versus time graph. Again, the velocity is positive, it's a positive slope, and it's a constant slope, so the velocity is positive and constant. Okay, now my velocity, well, this is a constant slope, right? And it's a positive slope. So my velocity is just the same. It doesn't change. My velocity never changed. So just some positive number, whatever, I don't care, whatever it is, and there you go, horizontal line. The velocity is positive. It's above the axis, not below the axis, which would indicate a negative velocity. And it's constant, straight line. Make sure you understand that. We're going to use it a lot in class and a lot in lab. Okay, for the next one, all I want you to draw is the motion diagram in the position versus time graph. All right. Okay, here we go. Okay. All right, so pause your video and draw your pictures. Okay, so we're back. All right, so I started out over here at some positive location. I ran in the negative direction. I started out slowly, and I kept going faster and faster. All right, so here it goes. I went to the left. My speed increased. That's what this shows. So my velocity is negative because I was going in the negative direction, and I was speeding up. And I forgot a ruler. That's a disaster. Can you stop, please? I got to go get